This video is in response to a question from Saqib Ali, and he asked me if I could help him with the integral of 1 plus sine x multiplied by e to the x with limits of negative pi and pi. So here we go, and hopefully this will help. Now on the left hand side I've written the integral, and over on the right hand side I've written the rule for integration by parts, and that's what we're going to use. Now the first thing, and probably the hardest thing, is to decide, well, what is u and what is dv by dx? Well, u is going to be 1 plus sine x. So let u equal 1 plus sine x. And then we've got dv by dx, and dv by dx is e to the x. Now what I want to do next is to differentiate the u term, so du by dx, and when we differentiate that we simply get cos x. We need to integrate this to get v, and that will give me e to the x. So we plug those into the rule for integration by parts, and what we get here is uv, so uv is 1 plus sine x times e to the x, so I'll just write it as e to the x multiplied by 1 plus sine x minus the integral of v, which is e to the x, multiplied by du by dx, which is cos x, with respect to x. Now what I'm going to do here is just deal with this integral here. So I'm going to deal with this part here, and then I'll come back to the whole thing later on. Okay, so what we've got is the integral of e to the x cos x dx. So I need to apply integration by parts again. Now I'm going to let my u term here be the cosine of x, and dv by dx will be the e to the x. Okay, so the rule is, and again if you need the rule, there it is at the top, it is uv, well u is cos x, and v, well that would be e to the x, so I'll just write it as e to the x cos x, minus the integral of v, and v is e to the x, times the differential of cosine x. When we differentiate cosine x, we will get negative sine x. So the negative and this negative here will make a positive, and that will be sine x with respect to x. So we've got e to the x cos x plus. Now the integral of e to the x sine x, you probably guessed, we'll need to apply integration by parts again. So this will be my u term, this will be my dv by dx term. Okay, so it's uv, so u is sine x, and the v is e to the x, so e to the x sine x, minus the integral of v, which is e to the x, times du by dx, and when we differentiate sine x, we get cos x with respect to x. Now what you might notice here is that we have this e to the x cos x here, and we've also got it here. So what I can do the following. I would get two lots of the integral of e to the x cos x dx is equal to e to the x cos x plus e to the x sine x. So hopefully you can see what I've done there. I've just added this to both sides. Now what we can do is we can divide that integral on the left just by 2 to eliminate that 2. So I'm going to eliminate this 2 here just simply by dividing by 2, and I'll do that to both sides. So what we get is the integral of e to the x cos x dx is equal to e to the x cos x plus e to the x sine x, and that is all over 2. Okay, so what we were working with this thing here. So we have to take the whole thing, so this here, all of this, and we're going to use that. So we've got e to the x 1 plus sine x, so e to the x 1 plus sine x minus, and we were subtracting the integral of e to the x cos x dx. Well, we know that is this here. So we're going to subtract that. So minus e to the x cos x plus e to the x sin x. And that is all over 2. Now we know that we have the limits of negative pi and pi. So the next step is to substitute in those limits. Now if you think about the graphs of sin x and cosine of x, let's do a quick sketch. So we'd have the sine function like this, and at pi, which is this point here, we can see that sine of pi is 0, and likewise sine of minus pi is 0. When we look at the cosine function, the cosine function, what we get is that at pi we have -1, and likewise at negative pi we also have -1. So let's put those values in. We would have e to the x, and x this time is pi, so e to the pi, 1 plus sine of pi is 0, minus e to the pi. Cosine of pi we know is -1, so we're multiplying by -1, plus e to the pi, multiplied by sine of pi, which is 0. I'll put it in, but we know that cancels. And that's all over 2. And then we're going to subtract when we pop in the negative pi limit. So we're going to subtract. Let's put in negative pi. So we're going to get e to the negative pi, 1 plus sine of minus pi, again it's going to be 0, minus e to the negative pi, and that's going to be by -1 plus e to the pi multiplied by 0, and that's all over 2. So we can see a lot of these terms will actually disappear. For example, this one here, that will disappear. We'll get a 0 from that one. We've also got a 0 from that one. And we can simplify things a little bit. So we've got e to the pi multiplied by 1. That's simply e to the pi. We've got two negatives here. We've got the negative here and here. That will give me a positive. So I've got a positive e to the pi over 2. And then we've got minus. Okay, so in the brackets here, we've got e to the negative pi multiplied by the 1. That's e to the minus pi. And then we've got e to the minus pi here times the -1. And we've got this negative here, makes a positive. And then we've got this negative. So we've got a negative. So minus e to the minus pi. And that's over 2. Okay, let's go ahead and simplify things. So we've got e to the pi plus e to the pi over 2. Well, that's going to be 3e to the pi over 2. And then we've got minus, and again, e to the minus pi minus e to the minus pi over 2. So that's minus 3e to the minus pi over 2. And obviously you can simplify and adjust that as you wish, but that's the answer I'm going to give you there. And hopefully, Sakib, hopefully that answered your question and give you a little bit of help.